Good morning, or I should say good afternoon, and happy President's Day, everybody. We are on our last lesson of this chapter on quadrilaterals, which is on kites and trapezoids. If you want to find this in your note packet, you will notice that there are very similar features to kites and trapezoids to the other parallelograms that we've worked with, but they also have their own unique set of properties which make them obviously different. Otherwise, they would be parallelograms as well. Okay, so here we go. So a trapezoid. A trapezoid is a quadrilateral with exactly one pair of opposite sides that are parallel. So that's probably the biggest difference between this four-sided figure versus our parallelograms is that it only has one pair of opposite sides parallel, whereas a parallelogram has two. So speaking of that, the parallel sides are called bases. Those are our bases. So that's what's noted here. And maybe you want to grab some colors from the bookshelf, or if they're highlighters on the round table, definitely maybe highlight these things. But here's a base, here's a base. And remember, we know that they are parallel because of those little arrows. The non-parallel sides are called our legs. The legs of your trapezoid. Again, those are noted here and here. Those sides are not parallel. They're just two segments. And then another property of our trapezoid is that consecutive angles between our parallel lines are supplementary. And that should make sense, right? Because these are still consecutive interior angles. So what I like to do, so I remember that, so I know angle A and angle D add to 180. And I know that angle B and angle C also add to 180. So I like to kind of draw that little motion there so I don't forget. Okay, perfect. So this is just our generic standard type trapezoid. But we also have one specific kind of trapezoid, and that is isosceles. An isosceles trapezoid, think of an isosceles triangle. And hopefully you remember an isosceles triangle has two legs the same, right? So an isosceles trapezoid is going to have legs that are congruent. So you want to mark that here. Here's our leg, and highlight that they are the same length. This guy is the same length as this guy. All right. All right, let's see what else we can fill in here. Our diagonals are also congruent. So these guys on the inside here, that diagonal is congruent to this diagonal. Now our base angles are congruent because they are opening the same distance. And maybe you want to grab a different color. These are good things to remember because it's a lot to keep track of. So like this angle here is congruent to this base angle. And then this base angle down here is congruent to this base angle. Your base angles are on your bases. And then lastly, our opposite angles, so the ones that are in opposite corners of your diagonals, are supplementary. Maybe we should label this. Let's label these and then we can write them down, okay? So let's just call this A, B, C, and D. So if we go up here, our base angles, that would be angle A is congruent to angle B. That's one pair. And then our other pair would be angle D is congruent to angle C. Those angles are the same. And then our opposite angles that are supplementary. So that would be like A and C. Angle A plus angle C equals 180. Those are opposite. And then angle B plus angle D equals 180. Okay? So a lot of information thrown at you right there, but like always, it gets a little easier when we see it with some numbers, okay? So let's practice finding these angle measures in our trapezoids. It says use the property of trapezoids to find the indicated angle measures. This one's pretty straightforward. We're just looking for the two missing angle measures here. So don't forget, we have parallel lines. So consecutive interior angles add to 180. So 180 minus 87 will give us angle M, which is 93 degrees. Same thing over here. 180 minus 51 gives us 129, which is the measure of angle K. Perfect. All right, another one just like that. Again, we have our pair of parallel sides. So I know an angle A plus angle D add to 180. So to find our missing one, we're going to subtract. So we get 118 for angle D. Same thing here. B and C should add to 180. So 180 minus 31 is 149. Perfect. Okay, this next one, I'm hoping you're noticing that, yep, we have a pair of parallel lines. And then we also see that it's an isosceles trapezoid because our legs are the same. So without any work, we already have another angle that's congruent to angle P. So here's a base, right? And what's its corresponding base angle? That would be Q. So these are both 112 because they are congruent. And now the process is the same as what it was before to find S and R. We simply subtract from 180 because these are consecutive interior angles. So only two different kind of angle measures when you have an isosceles trapezoid, which is nice. A lot of symmetry there. Things reflect over. All right, one more just like that again. We have our parallel bases. Our legs are congruent. Knowing that if angle X is 47, angle W is 47. And per usual, I have a typo because why not? Will you guys make this the measure of angle Z for me? How do we find the measure of angle Z? Well, we simply subtract from 180. And we get 133 for both Y and Z. All right. Hopefully we got a good grasp on how the angle measures work in our trapezoids. Now let's look at our legs and diagonals. We are told that MNOP is an isosceles trapezoid with NP equal to 16x minus 13. I'm going to write that right here. And O, 9x plus 8. PN is 5y plus 19. And MO, 12y minus 37. Yeah, we got a lot of information here. All right, so we are solving for our variables x and y. So since we are told it's an isosceles trapezoid, some things that you should be thinking is I know that my legs are congruent, base angles are congruent, and our diagonals are congruent. So if I look here at our legs, I can set these guys equal to each other because they are the same. All right, bring your x's to one side, your constants to the other. So we're going to have 7x equals 21. Divide out, x should be 3. That was pretty straightforward. Now we look at our y's here. If we look, those are on our diagonals, right? And since we have an isosceles triangle, our diagonals are congruent. So 12y minus 37 is equal to 5y plus 19. Bring your your variables to one side, so get our y's to the same side, and our constants to the other. Divide out. Y should be 8. All right, we're rocking. Next page, last page of our packet. Oh boy. This isn't right. Hold on. Let me see if it's out of order. Sorry, folks. Bear with me for a second. We gotta talk about what a mid-segment is before we can find it. There we go. Okay, here's our mid-segment. Now, again, math people aren't too creative, so it's kind of what you think would be a mid-segment of a trapezoid is the segment that connects the midpoints of the legs of your trapezoid. It's in the middle, right? How do you know if it's the mid-segment? Well, remember these tick marks are telling me that these two segments are the same, so they're going to be a midpoint. And then I have two tick marks, again telling me that that would be the midpoint. And if we connect them together, they are creating the mid-segment of our trapezoid. Some things to know about this mid-segment. That red mid-segment is parallel to our bases, and its measure is half the sum of the length of the bases. I didn't give you really a ton of space for this, and I apologize, but can we label some things on here? Let's call this B1, B2 for your basis. And your little formula for this, you add your bases together, and then divide by 2. That will give you your mid-segment, okay? That's your formula. B1 plus B2 divided by 2. We add them together to get the sum, and then take half of it. These are very straightforward examples coming up. We're told that MN is the mid-segment of our trapezoid QRST, and we're looking for X. So if I look at our formula we just wrote down, label them. It doesn't matter which one's your base 1 or base 2. I just usually go top to bottom. That's how my brain works. So 35 plus 20 all over 2. 35 plus 20 is 55. Over 2 is 27.5. And you can always double check, right? Is 27.5 between these two numbers, 20 and 35? I'm hoping you're thinking yes. Next one's a little different. This time we're given our mid-segment and one of our bases, and we're looking for a missing base. There's a couple ways you could do it. You could plug into the formula and solve for it that way. Or you can just kind of skip count, right? I know that these two distances have to be the same because of those tick marks. So what's the difference between 18.2 and 15? 3.2, right? And we're just skip counting. So I have to go 3.2 more away from 15 to get up here, right? So what's 15 minus 3.2? That's 11.8. If you're not really into skip counting, you're more of an algebraic mind, I'll just show you quick because this kind of comes up on your assignment. You can just plug into that formula, right? I know that x plus 18.2 all over 2 equals 15. That's your formula. Now, algebra your way out of it. How you get rid of divide by 2? Multiply both sides by 2. These 2's cancel. You're just left with the top. 15 times 2 is 30. How do you get x alone? Subtract over that 18.2. And you should be getting 11.8, right, when you subtract over, which is what we wanted. So that's what we got the other time. So either version works. You will probably have to rely on this algebraic version at some point in your assignment because there's variables thrown in there, but you guys are smart. You will figure it out just fine. Okay, in a nutshell, that's what you need to know about a trapezoid. We're going to shift gears now and talk about a kite. Kites and trapezoid, really, the only thing that they have in common is that they're not parallelograms, but they have 4 sides, okay? But besides that, there's not really much that they share in common. But a kite is a quadrilateral with exactly 2 pairs of consecutive congruent sides. Remember, consecutive means next to, congruent means equal. So here'd be a side that's congruent to this side, and this side is congruent to that side. So it's 2 pairs of congruent consecutive sides. They're next to each other, and they're congruent. All right? So if we fill in these blanks here, exactly 2 pairs of consecutive congruent sides. One pair of opposite angles that are congruent. So if we wanted to highlight that, if you're into highlighting on your notes, grab a little highlighter, folks. So there, that would be this angle here is congruent to this big angle there. So the angles that are between the two different sides are congruent to each other, okay? And then lastly, our diagonals are perpendicular. Meaning, what does that mean to us? I hope that you're thinking, oh yeah, I'm gonna have all right angles inside my kite. So now let's play around with some measures of kites. So it says, use the property of kites to find the indicated measures. We're looking for the measure of angle B and D. So a little bit different than like our trapezoids, right? But B and D, these would be our two congruent angles because they are between the two different sides that are congruent to each other. So how are we going to figure out their angle measure? Well, it's pretty simple. Don't forget how we started the chapter, right? We started by finding missing angle measures. So this is a four-sided figure, and we know that a four-sided figure has 360 degrees in it. We subtract away the angles we know, we're left with 232. And now I have to split that equally between angles B and D. So 232 divided by 2 gives us 116. So there we go. We're both 116 degrees. All right, next question here. Again, just looking for missing angle measures. This is kind of a bad picture, but this side's congruent to this side, and JM is congruent to NL. So if I'm just looking at my picture, we already know one of these angles without doing any math. Okay, what other angle is the same as angle L? That would be angle J, right? These two angles are congruent to each other. Now to find K, same thing. We know all four of those angles have to add to 360. So we just subtract away. And if my math is right, you should get 125 for angle K. All right, the next example is probably one of my favorites. I love these puzzle ones, right? We're trying to find all the missing angle measures. There's 7 of them here. If you maybe want to pause the video and try these on your own, awesome, go for it. I'm gonna though go ahead and start. But maybe before I start, I just want to point out to you guys that, do you notice that this top triangle is congruent to this big bottom one, right? That it's just a reflection over that middle dashed line, right? Right here. This middle dashed line is kind of like our reflection line. So if you can find half of it, you just reflect it over and you already have the other missing angles. Just kind of keep that in mind, right? Don't make it more complicated than it is. So using that, I would already know that angle 7 is 52, because these two angles are the same. And 65 would match angle 4 down here. So without doing any work, I already have 2 freebies. Now if you remember the properties of a kite, our diagonals are perpendicular, so all these 4 angles in the middle here are 90 degrees. And now it becomes pretty easy to find the missing ones. If we wanted to find angle 2, we just have a triangle, right? 180 minus 90 minus 65 should give us 25. And if angle 2 is 25, we would know that angle 1 is 25 because they're the same. And then if we look over here for angle 5, we're going to have 180 minus 90 minus 52. We should get 38. And 38 matches angle 6. And now, folks, I think we found all of our angles. So I would definitely take a second to fill in all the angles on the picture and then come back in and fill in this part down here. I think the picture is worth way more than the labeling of this bottom part, in my opinion. 52. All right, there we go. All right, folks, good work. On to our last example here. Again, we have a kite, and now we're switching gears to segment side lengths. So let's label what they give us. So AC is 38. So if I divide that by 2, I know that both of these chunks right here are 19. And ED is 41. And we are looking for what? CD right here. So if you notice, folks, this should be a right triangle. So what we're looking for, x would be our hypotenuse because it's across from that right angle. So x squared equals 19 squared plus 41 squared. Now just crunch her out. X squared, 19 squared is 361. 41 squared is 1681. Combine those on the right side, so 2042. Last step, take that square root. X should be about 45.2. Again, if I did my math right, I kind of cruised through this. You guys will have to let me know. Okay, thank you for being patient and watching this video lesson. I know these aren't the best. For you to summarize, you have 2 little sentence stems there. The first one is trapezoids and kites are similar to parallelograms because ... You guys finish that sentence. Trapezoids and kites are different than parallelograms because ... Fill it in. Show this sub your completed notes to get your worksheet. I will be back tomorrow. Thank you for being awesome. Happy President's Day. I will see you tomorrow. Goodbye.